Today, we're going to talk about asymptotes and rational functions to start with in section 2.6. And so I think that probably the best way as we go through this, since we have a test tomorrow, is just to look at some examples. And you can grab your calculator if you want, but I'm just going to do some sketches for you because I think it's easier to see it without the calculator. And we're going to talk about asymptotes. So the first thing that you should know is that when you're talking about asymptotes, a vertical asymptote is whenever the denominator, or in other words, the bottom of your fraction equals 0. So in this case, if I'm looking for a vertical asymptote, I'm looking at the denominator of my fraction, and I know that when that denominator is 0, then I'll have a vertical asymptote, or in other words, when x is equal to 1. A horizontal asymptote, on the other hand, is when you're talking about the limit of your function. And as your x approaches a positive or a negative infinity, that's what your horizontal asymptote is. So what you do is you look on your calculator and say, hey, if I go for a long, long ways, out forever, what will I be equal to? So let's just take a holistic approach and take a look at our function f of x and just think about that. The numerator here is a 1. Let's say I was going to choose an x value that gets really, really close to infinity. That's what this arrow stuff means. I'm approaching infinity on the x-axis or negative infinity on the x-axis. Let's talk about infinity. A really huge number, like 1 billion. Okay? In the denominator, if I stick in a billion, I'll have a billion minus 1, which is 999,999,999. 1 divided by that is pretty close to 0. So you're approaching nothing, 0. Now, limits are y values. So what I want you to also write down is that whenever you see this limit thing, these limits are y values. I think we've talked about that before in our class, but just a reminder. So my horizontal asymptote is what I'm approaching as I go out to the right forever on the x-axis or the left forever. And I'm approaching y equals 0. So this is my horizontal asymptote. And then if you were to type this equation into your y1, the 1 divided by x minus 1, you would see the following graph. In purple. And you can check that out later if you like. Laboratory learners. So for vertical asymptotes, the big idea is it's where the bottom equals 0. For the vertical, or sorry, for the horizontal asymptotes, this is look left and right on x-axis to infinity. A long time ago, back before the advent of biological and chemical weapons and stuff like that, wars were determined by the number of human beings you had on your side. So, for example, if I had an army of 1,000 people and you had an army of 10, you're in big trouble. So the more that you had, the more powerful you were, and you were the winner. Okay, that's just the deal. More people in your army, you're probably going to win. When we talk about limits, the thing I want you to realize, in case you don't remember, is that, or the most important thing, is that limits are y values. These are the super secret notes that I'm doing on a separate sheet of paper. Limits are y values. And whenever you talk about limits, especially when you get close to something, you're talking about what happens to infinity, usually for the x. Like you plug in an x value, what happens to infinity? So let me just show you some examples of what that means. If you see something like x cubed minus 2x squared plus 1,000. And on the bottom of a fraction, you see something like x to the 5th plus 10x minus 3. And I say, hey, as we look at this set of information, which of the 6 terms is the most powerful term?
X
to the 5th. It grows the fastest. It's the most powerful army around. Notice how the numerator does not have something to the 5th power. Do you see that? If I look at that and I ask you the question, what is the limit of this thing as x turns into infinity? Your answer is going to be 0. Because as the bottom blows up, because it's the most powerful, nothing else can compete with it. What I talk about when I talk about this is, whenever you're talking about the limit as x turns into some kind of an infinity, of something that's small on the top, like the army, over something that's big on the bottom, you get 0. So small power on the top, big power on the bottom, 0. X cubed is smaller than x5. X cubed is small, x5 is big. The rest of the terms, who cares? The biggest term on the top was a cube. The biggest term on the bottom was a 5th power. Okay? Second scenario. What happens then if instead I see something like the limit as x is turning into infinity, and this time I put the big power on the top, like x to the 7 plus 3. And on the bottom I put something like x to the 4th plus 1 million. Where's the big power? On the top. So if I'm looking at the limit as x turns into infinity of something that's big on the top or something that's small on the bottom, this always turns out to be some kind of an infinity. And you'll have to watch the signs to see what that means. So like in this case right here, I see no negative signs associated with the powers. Like x to the 7th is not a negative. So I have a positive thing over a positive thing. To begin with, I don't know what I'm plugging in. If I plug in a positive infinity, I would have infinity to the 7th over infinity to the 4th. The top wins and everything's positive. So it's positive infinity. If I put in a negative infinity instead, then on the top I would have negative something, huge. On the bottom, since it's to the 4th, I'd have positive. Negative divided by positive is negative. I would have a negative infinity as my answer. Negative 1 billion divided by positive 1 is negative 1 billion. So just watch for the signs, I guess is all I'm saying. Moral of the story, first one. The limit of small over big as you go to infinity is 0. The limit of big over small as you go to infinity is infinity. And the last example, before we finish off our notes for 2.6, that I want to show you, goes like this. What happens if you see something like the limit as x approaches infinity? I'm still approaching infinity, but this time I see something like 3x to the 4th minus 10 over 7x to the 4th plus 1 million. And what do you notice about the powers on the top and the bottom?
They match.
They match. Whenever that happens, what you do is you look at this. You're done. So when the powers, when the armies are equal, you look at the coefficients. These rules only work with limits as x approaches some kind of infinity. Okay, next example talks about asymptotes and graphing. So the first thing I like to do is I like to do vertical asymptotes. So vertical asymptote, remember, was where the bottom was equal to 0. So I look at the bottom being 0. Where's the bottom 0? At x equals -1. On your exam, if you don't write down x, I'll probably make a mistake. I do it all the time. I'll probably write it down y on your test equals, and then it's going to be wrong. So make sure you have x. X is -1. So here's the x asymptote, or in other words, the vertical one. The horizontal asymptote is the limit as you approach infinity. So the limit as x goes to infinity of your function. Remember, that's about war. So as I look at that, I'm looking at the top for the war and the biggest thing on the bottom for the war. What do you notice?
They're the same.
They're the same. So the answer is?
5 or 1 or just 5. Y equals 5.
Very good, Joe.
Yes.
Y equals 5. So now I have two asymptotes. And then we're supposed to graph it. Now if you look on your calculator, what you're going to find out in this graph
You can do that because of the lead coefficient.
correct. And again, you get to use your calculators on this test so you can see that it crosses through 0, 0. The biggest thing though, I'm going to be looking for your asymptotes. If they're not correctly labeled, if you don't have -1 here, 5 there, and write down x and y equals, you're not getting credit. Make sure you put down x and y equals. Very, very important. Number 3, same exact deal. We're going to graph this one. This one's kind of weird. What's different about this one?
That there's an exponent on the bottom.
There's an exponent on the bottom. So, remember, we want the bottom to be equal 0. Joe?
Your y limit is 0 because you're.
Okay, so my y limit, so that's the same as what kind of an asymptote?
Horizontal.
Horizontal. So my horizontal asymptote is y equals 0 because the top power is smaller than the bottom power. War. Talk to me about my vertical asymptotes.
Vertical asymptote would be x equals 1. Or -1.
Yes. Both are correct and necessary. So your vertical asymptotes are x equals positive or -1 because both make the bottom 0. -1 squared is positive 1, so you have to use both. Bless you. Here's -1. Here's positive 1. And you can check this on your calculator later. I'm not really worried that you can type this in your calculator. Don't forget to put parentheses around the denominator. This is what your graph would look like if you graph it on your calculator. You see a piece over here. You see a piece over here. And crazy enough, you see a piece right here. And number 4, in my function,